In this video, we'll be looking at linear and angular speed. Now recall the formula, distance equals rate times time. If we take this formula and divide both sides by t, we get our formula for rate, or linear speed, which is rate equals distance divided by time. Now you recognize linear speed as miles per hour, feet per second, and so forth. Now, if S represents the distance along an arc of a circle, and V represents the linear speed, then we can rewrite this formula for linear speed as V equals S over T. All we did was sub in S is our distance, only this time it's a distance along an arc. Now we know from previous lessons that S is equal to the radius times the central angle, so S equals r theta. So we can sub in this expression, r theta, in place of S, and we can write V equals r theta over t, where r is the radius and theta is the measure of the angle. Now remember that theta must be in radians if we use this formula. So another formula for linear speed is V equals r theta divided by t. Now formula for angular speed is omega equals theta over t, where omega is in radians per unit of time and theta is in radians. Now you'll recognize angular speed because it'll be in radians per minute or revolutions per second. Right? Then to relate linear speed and angular speed, linear speed we know is r theta over t, and angular speed is omega equals theta over t. We can see that this theta over t is in both expressions. So we can write velocity, v, is equal to r times omega. So that'll give us another formula that we can use if we need it. Okay, so the example that we're doing, suppose that P is on a circle with a radius of 15 inches and ray OP is rotating with angular speed pi over 12 radians per second. The first thing we want to do is find the angle generated by P in 10 seconds. Well, since P is rotating at pi over 12 radians per 1 second, all we need to do is multiply that by 10, and we get pi over 12 times 10 is equal to 5 pi over 6 radians. That's the angle generated in 10 seconds. Our next thing that we're asked to do is find the distance traveled by P along the circle in 10 seconds. Well, we know that the angle, the central angle generated in 10 seconds is 5 pi over 6 radians. So we can use the formula S equals r theta to find our distance. We know that r is 15 inches, that was given in the problem, and then theta is our 5 pi over 6 radians. So we have S equals 15 times 5 pi over 6. Do the math and we get 25 pi over 2 inches is the distance traveled in 10 seconds. Next thing that we're asked to do is find the linear speed of p in inches per second. Now I want to show you all of the formulas, and you can choose. I won't do this every time, but this time we want to find the linear speed, so we can use this formula where velocity equals arc length divided by time, or we can use this formula, velocity equals radius times the measure of the central angle in radians divided by time, or we can use this formula, velocity equals radius times the angular speed. So if we use the first one, if we use the first formula, we know that our arc length is 25 pi over 2. We found that in our previous problem. Divided by 10, which is our time, and we get 5 pi over 4 inches per second. If we use the second formula, we know that our radius is 15, our central angle is 5 pi over 6, and our time is 10. Simplifying this fraction, we get 5 pi over 4. And then if we use the last formula, we know that our radius is 15, and our angular speed is pi over 12 radians per second. So we get 5 pi over 4 inches per second.